Okay, we've now got working code and we can make requests to our API server and get JSON data in response and get the HTTP response and everything's fine. But what we've done here, if we go back and take a look at our code, is we've used synchronous code here. This action result and finding the user and returning the user, this is referred to as synchronous code that we're using inside .NET. Now what we would typically do, and what is considered best practice to do, is to use asynchronous code, especially when we're making things like queries to our database. And often to describe synchronous versus asynchronous, the waiter and restaurant analogy is used. Supposing you go into a restaurant, you order your food, the waiter comes over and takes your order. The waiter then goes to the chef to give him the order, but instead of the waiter doing something else and going to take other orders, he waits around until the chef has completed cooking the food and then takes you back your order of food. In the meantime, there could have been 7, 8 different customers turn up, but they're not getting served because the waiter is waiting for the chef to cook the food. In the asynchronous world, the waiter delivers the order to the chef, and then the waiter carries on taking more orders, delivering those orders to the chef. And when the order is completed, the chef rings a bell, the waiter goes and picks up the food and then delivers it to the table. That's one way to look at asynchronous code. So we're going to turn effectively what is synchronous code that has the potential to block a request going to the database and make this asynchronous. And to do that, we need to do a couple of things. First of all, we need to tell our method it's going to be asynchronous, and we do that by using the async keyword at the top here. And what we return is different. We no longer return just an action result, we return a task that contains an action result. So we wrap our action results inside angle brackets. And then we get a warning telling us that we've given a method the async keyword, but we haven't used await anywhere inside it. So in order to make this an actual asynchronous method, we can await the part of the code that has the potential to block our requests. So we use the await keyword here, but then we also use the asynchronous version of this method. So we'll say toList async. And we do need to import something to use this, or add a using statement from Microsoft Entity Framework Core in order to use the asynchronous version of the toList. And then everything else stays the same. We return users in exactly the same way. And we can also do the same for the HTTP GET request here as well. Same thing again, we notify the method it's going to be asynchronous. We return a task that contains the action results, and then we have the ability to await the database request and use the asynchronous version of that method. Now what does this mean in reality? Nothing's changed. If we go back to Postman and we make the same request to go and get our users, well, first of all, we've got an issue. And it tells us the request matched multiple endpoints. Well, does it really? Because if I go back to the code, then I didn't change the endpoints. Everything is exactly the same. But I want to emphasize this point because what we didn't do after making code changes, and what we didn't do, is check the terminal to see if anything needs restarting. Now, what you may see is that hot reload of changes succeeded. But they didn't really succeed because our code is not working. Something is broken. But nothing is really broken. It's just our code changes haven't been picked up by hot reloading. And this is one of my least favorite things about .NET just now. They've introduced something called hot reload, and it doesn't really work very well at all. Certainly not in comparison to what we're going to use soon, which is Angular, where the hot reloading really does work quite well. In the world of .NET, especially with API controllers, I feel that hot reload is not designed for this yet. Maybe one day, but not currently in .NET 8. So if we do see a problem, then the very first thing we need to do to troubleshoot this problem is not consider it a problem until we can persist that issue after we have stopped our API server and then restarted it by executing .NET Watch again. Now, if our issue persists after we've restarted, then we know we have a problem to investigate. But obviously, if the issue does not persist after we've restarted, we know there wasn't a problem in the first place. We just fell over because of hot reloading. So if we go back to Postman and we re-execute that request, we will know if we have a problem that needs to be investigated. And if I click send, sure enough, we do not have an issue. It's just hot reloading failed, and we can now get our response. And if we check the other request, the other endpoint, to go and get all the users, then we can see that we've got our users coming back. Now, just to emphasize the point, you're not going to see any performance difference between what we had before and what we have again. And there is a small amount of overhead to using asynchronous code versus synchronous code, but it is completely negligible. And the benefits we get, particularly in terms of scalability, then if our web server only had a set number of threads available, then those threads could be blocked if we're using synchronous code. If we're using asynchronous code with the same number of threads, it's capable of handling much more requests because it can delegate the task to other threads and still respond to other requests. And it's just considered normal best practice to use asynchronous code for database queries than synchronous code, even though on this training course, for the size of the app that we're going to create and the number of users that potentially will use it because it's just a demo app, we will not see the benefit of using asynchronous code, but it is best practice to use code in this way, particularly when making database requests. So this brings us to the end of the first part of building our API, which is just to confirm that we can save our data into a database and we can retrieve data from the database and return it to a client. So when we get to the end of a particular section, we're going to save our changes into source control, and we're going to use Git to do that. Now, one of the things I did not mention about you needing to have installed earlier is Git. And if you do not have Git installed already, just go to Git SCM and download and install the version of Git available for your operating system. It will give you an installer. Just run through and go ahead and install this. And in the next lesson, we'll make use of this to save our changes into source control.